care if anybody gets it. I'm going as the Doppler effect.
No, it's not.
If I have to, I can demonstrate. Meow.
Hello, my name is Jake Cohen. This is Mitchell DeConing and Daniel D'Souza. We are members of Team Popeye, and the physics concept we will be looking at today is the Doppler effect.
So, what is the Doppler effect?
Would you care to elaborate?
Okay, so the Doppler effect is the change in frequency as measured by an observer due to the motion of the source or the motion of the listener.
A good simple way to demonstrate the Doppler effect is this picture. We have a bug in the center, and it is jumping up and down in the middle of the pond, making an even sound wave going to listener A and listener B in that position. In this picture, it's moving towards listener B. And you can see in this picture how on the listener B side, the waves are kind of moving closer together and they appear shorter. This is the Doppler effect. Basically, since the bug is moving towards listener B, the source of the waves is closer to listener B, and the waves have to travel less time to get to person B.
Now we're going to look at this diagram that replicates the Doppler effect. If we look at the fire truck, it's the sound source in this picture, and the person is the observant. And because it's moving towards the person, the sound waves would have to travel a short distance since it's moving in that direction. This would give the listener kind of perception that the frequency is a bit higher than what it would be because it would sound like the wavelengths are a bit shorter.
We're going to have Dana and Daniel in a car. They're going to be playing a 200 hertz tone through the speakers while driving past us. Basically what we're hoping to demonstrate with this is the Doppler effect, in that when they drive past us, as soon as they get in front of us, there will be an apparent change in frequency. No, there really isn't one, but it'll sound like the sound got higher, even though it didn't.
Are you ready for this experiment?
Well, I think that the experiment where we had the car going past the camera, which represented the viewer, I think the apparent change in frequency and tone that was picked up by the microphone effectively demonstrated the Doppler effect. And I think the example with the bug hopping on water creating the waves was a definitely good illustration of what it is in a more basic way.
Right.
And from the experiment we were able to tell that it's relative to where the person is. So it takes different effects, so if you're actually in the car, you wouldn't be able to tell the difference rather than that person who was standing at that one point.
Yeah, because you're at a constant distance from the sound source. And the thing with the Doppler effect is that it's all relative to the position of the listener and the source of the sound.
So I kind of think in the recording arts industry, we have to try to make it as realistic as possible, but at the same time, we have to make it appeal to the audience. Like for example, in a movie set or in a movie scene kind of thing, we wouldn't be able to use the actual Doppler effect because it would be clashing with the voiceover or with the person talking. So we'd have to kind of emulate it by pitch shifting it.
So like making a fake version of the real thing to make it sound even better.
Yeah.
And understanding how to do that is important for our jobs, and it's just simple physics.
Yeah, because people are used to hearing this everyday kind of phenomenon where you can hear the Doppler effect as the car is moving by.
Yeah, that's what the sound effects in the post-production jobs are all about. I mean, we've seen that sound effect in millions of movies.
Yeah.
Kind of just like the
It's made artificially by taking the sound and doing automation with the pitch shift, slowly raising the frequency, automating the volume to compensate for the changing distance, and automating the panning, which means it's going from left to right to give the effect that is what it's doing. As the vehicle is doing it.
I noticed talking about volume now. We know that the Doppler effect doesn't change volume, but it's volume due to because the car's coming closer to the person.
I hate what Sheldon's supposed to be.
Oh, he's the Doppler effect.
Yes. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Hello from Stone Castle. Oh, it's burning my eyes. The sun is burning my eyes.
Squad.
Hello, my name is Jake Cohen, and
One second, I need to.
Hello from Stone Castle Apartments. This is. Fun fact: it was made by a guy from Australia with the last name Doppler. There.
Team Papa.